What's up, everybody? It's Dan from SageMathTutoring.com, and this is another video for you guys. So this is for a student, and really any student who needs help or extra practice with solving for variables. So what is a variable? Well, a variable is a letter that's obnoxiously in this equation, and the letter represents an unknown. So it's like 23 plus something that we don't know equals 64, and your job is to figure out what is that something that we don't know. Okay, now typically the teacher is going to want you to go about this in a textbook fashion, which means your teacher is going to want you to isolate the variable and get it so that n equals blah, 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 blah. So there's just an n on the left-hand side of the equal sign and just a number on the right-hand side of the equal sign. So that's the goal. We want to get n by itself. So how do we do that? Well, we ask ourselves, is n by itself right now? No. If it's not by itself right now, what's in the way of n being by itself? Well, clearly this 23 is in the way of n being by itself. What's 23 doing to n? 23 is being added to n. So how could we get rid of 23? Well, we would subtract 23 from this side, because if you subtract 23 from this side, it's going to cancel that 23. Now, in algebra, you're not allowed to do one thing to one side of the equal sign without doing the same thing to the other side of the equal sign. So we're going to have minus 23 right there. Now, once again, the whole point of subtracting 23 from both sides is to get rid of these, to cancel those out. So we're going to cancel those out, and then you end up with n equals, and then you have this thing where it's 64 minus 23. Now, my student at home needs to pay very close attention to what to do with this. It's very important that the fundamentals of subtraction are intact here. So we have 64 minus 23. Okay, so it's 4 minus 3 is 1. 6 minus 2 is 4. So clearly the answer is 41. Now, the teacher also probably will want you to, quote unquote, check the answer. And you do that by plugging 41 back in for n. So you could always go right back up here. And you could say, okay, 23 plus 41, does that equal 64? Okay, notice how this red equation is the original black equation here. I wrote a little question mark because really that's what you're checking. You're checking to see if that's true. And you could always double check where it's like 23 plus 41. Let's do that off to the side. I'm going to put the larger number on top. 41 plus 23. And then we have 4. And then we have 6. So that does indeed equal 64. So 41 is most definitely the answer. A lot of teachers will like it if you put a little box around the answer. So that's how you do that one. So based off of that, I would like my student at home and all students who are watching this to at least pause the video and try this, and then unpause it, and I'm going to do it. Okay, so our goal is to get this b by itself. So what we're going to do is we're going to subtract this 9 from both sides. And then that results in these being canceled. And then we have b over here. Now, what is 20 minus 9? 20 minus 9. Well, this 0 is not large enough to subtract a 9. So we're going to take a tens away from there, turn that into a 10. And hopefully my student at home recognizes that if you have a number in the units column that's too small to subtract the number directly below it, well, you would take a 10 from the next row over, or the next column over, you turn that into a 10, and you drop this down 1, okay? So this actually becomes 10 minus 9, and 10 minus 9 is 1, and this right here becomes 1 minus 0, which is just 1, okay? So b equals 11, all right? Now, I know that this process is tedious. I would strongly advise my student doing that at home, practicing that. By the way, anyone who's doing this video should definitely have scrap paper and be trying this on your own. So we have b equals 11. So in red, we're going to check. So instead of writing b plus 9, I'm going to write 11 plus 9 equals 20. And then I ask myself, well, is that true? Well, 11 plus 9, let's see. 11 plus 9. That's going to be 1 plus 9, which is clearly 10, and we're going to carry the 1, and we're going to add this one plus this one, and that gives us 2. So yes, it is true, and therefore this is the answer. Moving on. Okay, so this is pretty much the same thing, only now you have the k on the right-hand side. You're still going to want the k to be by itself, only this time you're going to have k equals some number over here. Okay, so it's okay to leave the k on the right-hand side as opposed to the left-hand side. That's totally fine. So pause the video, try this one, try to get k by itself on the right-hand side this time, and then unpause, and then I'm going to do it. All right, so basically what you would want to do is you'd want to get k by itself, so you're going to subtract 9 from both sides. And the reason for that is because we want these 9s to cancel. That is definitely going to give us k equals something, but what is that something? We have 17 minus 9. Well, what is 17 minus 9? I'm going to do it over here. 17 minus 9. So one way to think about this, unfortunately, if we did that other trick, we'd still be left with 17 minus 9. One way to think about this is 17 minus 10 is clearly going to be 7, right? Because 7 plus 10 is 17. But we don't want to subtract that much. So 17 minus 9 is 8. This is one of those things where, unfortunately, the teacher is going to want you to memorize. Okay, this is kind of like a flashcard situation. 17 minus 9 is 8. So this is going to be 8 right there. And basically, let's see. If you were to check that, that would be 17 equals 8 plus 9. Well, is that true? Yes, 17 does indeed equal 8 plus 9. If you were to add 8 plus 9. Again, that's sort of a flashcard situation where you just got to memorize 8 plus 9 is 17. You could always use your fingers, be like, put up, 8 and then count on your fingers and all that stuff, right? But hopefully at a certain point you have it memorized. So that's that one. Okay, please try this one. Pause the video, give it a shot, unpause it, and then I will do it. Okay, so for this one, we're going to want q on the right. And in order to do that, to get q by itself, we're going to subtract 26 from both sides. And the reason for that is to cancel. And then we're going to have q equals some number. But what is that number? Well, the number is going to be 44 minus 26. I am going to do that off to the side. That's not a flashcard situation. That is a little bit more like a situation worth writing down and working out. So this 4 is too small to subtract the 6. So what I'm going to do is I'm going to turn that into a 14. So that becomes a 14. But anytime I do that, I have to take 1 away from the next column over. So that becomes a 3. You just kind of do all that first and then go. So we have 14 minus 6. Well, that's clearly going to be 8. We have 3 minus 2, which is clearly going to be 1. So we're going to have 18, and that is the answer to that one. It's not 8, by the way. I believe my student put 8 as the answer. That is not the right answer. Unfortunately, my student is going to have to practice this 44 minus 26 stuff. Turning the 4 into the 14, turning this 4 into a 3, and then taking it from there. So we have q equals 18. The question is that true? Well, let's check. 44, writing the original equation. 44 plus not q, but 18 plus 26. Is that true? I don't know. Let's see. Is it true that, this 18 plus 26 equals 44? Let's find out. We're going to have 26 on the top because I like the larger number on the top. We have 26 plus 18. What happens here? We have 6 plus 8. That is going to be 14, so it's a 4. We're going to carry the 1. And then we end up with 1 plus 2, which is 3, plus another 1, which is 44. So that is indeed 44. So yes, this answer checks out. Moving on. Okay, so this is the first of its kind. I'm just going to do this one because we want to get c by itself, but we have this weird situation where it's a negative 13 over here. We want to get rid of that negative 13. Well, the way to get rid of a negative number is to add that number. So all you have to do is go plus 13, and then they end up with c equals 18 plus 13. Let's do that off to the side, 18 plus 13. Well, we have 8 plus 3, which is 11. I'm going to put the units digit of 1 there. I'm going to put the other tens digit of 1 there. And then we have 1 plus 1 plus 1. Well, clearly that's going to be 3. So that's 31. And that is the answer to that one, except we need to check. So we're going to check 13 plus 31 equals 18. Is that true? That's the question. Is that true? Well, we have a sort of annoying situation where we have a negative over here. You know, negative 13 plus 31 equals 18. What is that? Okay. Well, here's what I want my student to do at home for this one, just to avoid confusion. I tried presenting this sort of number line way of looking at negatives. It didn't seem like that was clicking. So one thing you could do with negatives, like it's negative 13 plus 31. Well, the bottom line is the commutative property means that we could totally switch the order, where it's like, you know, it's okay to rewrite that as 31 plus negative 13. That's okay. Okay. We just change the order of these two. You could totally do that. Also, my student, I do recall, remembers that when you add a negative number, these two just turn it into a negative symbol or a subtraction symbol. So up here, we're going to rewrite it as 31 minus 13, and that equals 18. And then the question is, what is 31 minus 13? Well, let's go off to the side for that. 31 minus 13. Well, we're going to turn this into an 11, and we're going to take away, 10 from there, so we're going to have 2 there. So then we have 11 minus 3, and this should really be a slash through there. 11 minus 3 is 8, and then we have 2 minus 1, which is 18. And yes, that checks out. It is true that 31 minus 13 equals 18. You know, this 18 or this 18. So it is true that negative 13 plus 31 is 18, because you could just switch the order here. All right, so hopefully my student at home maybe likes that better. That might be a better way of looking at it for my student. So that we have C equals 31. That's definitely true. So I'm going to put a box around it. Please try this one on your own. Pause the video, see how it goes, unpause it, then I'll do it. Okay, so for this one, we are going to have to immediately add 19 to both sides, because in order to cancel out this negative 19, well, all you have to do is add 19. So we're going to go plus 19, plus 19. Obviously that cancels, which is why we're doing it. It's going to be Z equals something, but then the question is, what's 6 plus 19? Well, I'm going to go off to the side, put the larger number on top. It's 19 plus 6. Okay, 9 plus 6 is 15. Okay, something worth memorizing. Carry the 1. 1 plus 1 is 2, so that's 2, so that's 25. So we have Z equals 25. As usual, we're going to check that. So Z is 25 maybe, right? We're going to double check. So 25 plus negative 19 equals 6. Is that true? Well, this plus minus, stuff, that just becomes a subtraction symbol. So we're going to have 25 minus 19 equals 6. Okay, 25 minus 19. Let's go up here to do that. 25 minus 19. So the 5 is too small to subtract the 9. So once again, we're going to turn that into a 15. And we're going to turn that into a 1. So we then have 15 minus 9. What's that? Well, hopefully, flashcard-wise, you know that that is 6. And then we have 1 minus 1, which is just 0, so we don't have to write that. So 25 minus 19 is indeed 6. So we are good to go. That is the answer. We just got the answer. Z equals 25. Moving on. Okay, so for this one, we have plus 68. We have a negative number here, so we're going to be careful with that. So we want to get h by itself, so we're going to subtract 68 from both sides. So we end up with h equals some number. But what is negative 23 minus 68? All right, negative 23 minus 68. So what I'm going to do is I'm going to bust out the number line for this, because I think actually we really do need to sort of perceive what's going on the number line here. So with this situation, you can imagine we have a number line where you have 0 here. Imagine this is like negative 23. And basically we're subtracting 68. So we're starting on negative 23. There it is. Maybe we could put a man there, right? So it's negative 23 minus 68. So the first number tells you where you put your man. What you're doing here, this is a subtraction, that tells you which way he's facing. So he's facing left. So that's a nose, that's a huge nose. 68 steps. So 68 tells you how many steps he's going. So he's going 68 steps in that direction. Do you see how that makes him more negative? So 0 is right here. All the positive numbers are over here, but he's going all the way in that direction. 68 steps, right? 68 steps. So then the question is, 23, he's going 23 plus 68 in this direction. So the question is, what is 23 plus 68? 68 plus 23 is 8 plus 3 is 11. Carry the 1. We're going to have, 6 plus 1 is 7 plus 2 is 9. So we're going to have 91. So he's going to end up at negative 91. All right? So we went 20. He was already at 23 in the negative realm. And then he went even more negative, 68. So that's going to be negative 23 and another negative 68 in that direction. And that gives us a negative 91, okay? So at the end of the day, that turns out to be a negative 91. So we're going to have negative 91 there, okay? So that is that. Now, I am running out of time because I have a very booked schedule. So I'm going to ask my student at home to plug these numbers back in and check. And just remember, my student at home, when you're being tested on this stuff, it's probably the case that your teacher is going to want you to actually plug this stuff back in and check. Okay? All right, so we have a plus 3 equals negative 43. A plus 3 equals negative 43. So in order to do this, we got to subtract 3 from both sides. And that's going to cancel that, and we're going to end up with a equals, and we have negative 43 minus 3. Well, similarly, that's a number line scenario where you can imagine 0 is right here. You can imagine a negative 43 is right here, and that's where your man is standing. This subtraction symbol tells you which way he's facing. He's clearly facing left, and this 3 tells you how many steps he's walking, so he's clearly walking 3 steps in that direction, and then he ends up, there. I'm not going to draw it because it's going to get too messy, but he ends up there. And so therefore it's negative 43 minus another 3 in that direction, so that's going to be a negative 43 minus 43 minus 3 rather is going to be negative 46. So hopefully my student got that. I didn't ask him to do. Pause the video for that one, but I will from here on out. So hopefully that makes sense. Moving on. Okay, so what we have here is a negative 5 equals p plus negative 7. The first thing I would do is simplify both sides so it's a little easier on the brain. So we have negative 5 equals p minus 7, okay? So that's the first thing I would do there. So if my student at home wants to pause the video from here to solve this one on his own, he should do so. And here's the answer. So in order to get p by itself, we got to add 7 to both sides. And therefore, we're going to have p equals, negative 5 plus 7. But what is negative 5 plus 7? Well, the good news is, with negative 5 plus 7, you could totally, I'm just going to draw a little divider here. You could totally re-represent that as p equals 7 minus 5, because you could just switch the order, and then we end up with p equals 2. That should be the answer. We'll leave it to my student at home to check and see if that's right. All right, looking at this one, if we want to get a by itself, we got to get rid of this negative 2. How are we going to do that? We're going to add 2 to both sides. So if my student at home wants to pause the video and try it, he should right now. And here is what happens when you do that. You go plus 2, boom, boom, and then you end up with a equals, well, what's negative 7 plus 2? What's negative 7 plus 2? Well, that's a tough one. I mean, I could rewrite it as 2 minus 7. I could do that flipping thing where it's like I go, instead of writing, negative 7 plus 2, I write 2 minus 7. I could always do it that way. But the thing is this is still confusing because it's like 2 minus 7. Like, what the heck is that? Well, the bottom line is it doesn't matter which one you pick here. Let's pick the bottom one, like whatever, and do the number line thing. So imagine, here's a number line, and you're at 2. You have a man standing at 2. and it's 2 minus 7, so that tells us which way he's facing. He's facing left. And 7 tells us how many steps he's walking. So he's walking 7 total steps. So that's going to be 2 in this direction plus another 5 in that direction, right? So here he is now standing here, and he had gone 5 in that direction and 2 in that direction, right? So what is that? Well, that is a -5. He is now at a -5 on the number line. Hopefully that makes sense. This is something that maybe my student will have to practice a little bit more, and that's fine. So we have -5 as the answer to that one. I'll leave it to my student to check that one. Moving on. Okay, so this is absolute value. So the first thing you want to do with this is just rewrite that, because anything that's negative inside absolute value symbols just turns out to be positive. So I'm going to rewrite this in a way that's easier on our brain. So we have 0 equals h plus 14. And then you would just take it from there. So my student at home, pause the video, give it a shot. All right, so if you want to do this, you have to subtract 14 from both sides, and you end up with h equals -14, because that is what 0 minus 14 is. It's -14. In case that's confusing, here's a number line. There's 0 is going to be 0 minus 14. What's that? Well, 0 is where you start. There's a man. The subtraction symbol is which way the man is facing left. And he's walking how many steps? Well, he's walking 14 steps in that direction. And that is clearly -14. Okay, so that's that. So I leave it to my student at home to do this one on his own. Go ahead, pause the video, give it a shot. All right, so hopefully my student did the following. We have -1 equals m plus 2, because this absolute value is really just plus 2, right? So then we end up with -2, and then you end up with m equals, that cancels, m equals, what's -1 minus 2? -1 minus 2. -1 minus 2. Imagine that number line scenario. Imagine we have a 0 right here. We have a -1. We have a man standing on -1. That's where we're starting. He's facing left. He's walking 2 steps in that direction. Here he is now. Where did he end up with? Well, that's -1, -2, -3, right? So he is at -3, and therefore the answer is -3. Hopefully my student got that. Moving on. Okay, so then we have B, blah, blah, blah. This is very straightforward. Please pause the video, try that. Let's see if you get it. All right, hopefully you tried it. If you're not trying it, then this probably is awkward sounding, because I keep saying, please try it, and then I pause, and then I just do the problem, so it's kind of weird. So we have B equals, okay, 65 minus 14. We're going to go off to the side with that one. 5 minus 4 is 1. 6 minus 1 is 5. So therefore it is 51. Hopefully that makes sense. Hopefully that's what you got. Moving on to the next one. Please pause the video. Try this one. Go ahead. All right, well, we want to get h by itself, so we're going to have to subtract that 71 from both sides. Subtracting 71 from both sides. And as a result of subtracting 71 from both sides, obviously these cancel. And then you end up with h equals, okay, what's -90 minus 71? Okay, once again, the number line. Let's get an idea of what the heck's going on over here. We have a number line. We have a 0 over here. Imagine you start at -90, and there's a man there. And it's going to be -90 minus 71. So which way is he facing? According to that minus symbol, he's facing left. So there's his nose over there. How many steps is he walking? He's walking 71 steps in that direction. So he's already 90 steps in that direction. And now he's walking 71 steps in that direction. So hopefully you could see that, first of all, this is going to be negative, right? But the question is, what's the number? Well, in a way, it's kind of this weird thing where you can temporarily add 90 plus 71. And just remember that it's negative, though, right? So let's do that. 90 plus 71. Adding the units column gives me 1. 9 plus 7, what's that? That's 16. That's 161, therefore. So that's going to be a -161. Hopefully that makes sense. -161. I leave it to my student to double check that. Moving on. Okay, so this one is actually written wrong. So I'm going to fix that. So that should be that. Okay, so this is the first time we had to deal with an exponent. So 3 squared is really just 3 times 3. The 2 means how many times you're multiplying this larger number times itself. Well, we're multiplying this larger number times itself twice. So that looks like this. It looks like it being multiplied to itself twice, right? and that's 9. So therefore, we're going to have negative 1 equals r plus 9. I would definitely do that first because, honestly, that's PEMDAS. PEMDAS thing. That says, apply the exponent before you do any addition or subtraction. Apply the exponent before you do addition or subtraction. So we have r plus 9 equals negative 1, or negative 1 equals r plus 9. So we're going to subtract 9 from both sides, and then we end up with, this is going to be a negative 10 for all the aforementioned reasons, and we're going to have r, and that is the answer to that one. All right, 2 to the 5th, a little bit trickier. I still nonetheless leave it to my student to pause the video, try this one out on his own. All right, so let's work this one out. We are going to try to figure out what 2 to the 5th is. Let's do that first. So it's 2 times 2 times 2 times 2 times 2. All this is being multiplied together. Well, this 2 times 2 is 4. This 2 times 2 is 4. And that's really just another 2. That's just 2. And then 4 times 4 is 16. And that's still that 2 there. And 16 times 2 is what? 32. If you were to work that out, 16 times 2. 6 times 2 is 12. Carry the 1. 1 times 2 is 2, plus that 1 that we carried is 32. So we end up with negative 4 equals t plus 32. Okay, subtracting 32 from both sides. We end up with t, cancel. We end up with t equals negative 4 minus 32. Hopefully my student, based on the number line, if you did the number line trick, which I'm not going to do anymore, negative 4 minus 32, that tells you where your man's standing, that tells you where is your man facing, that tells you how many steps he's walking, and that's going to turn out to be negative 36. And that is the answer. Hopefully, unless I made a mistake, I could always have made a mistake. I don't think I did. I leave it to my student at home to check that one. Moving on. All right, once again, we have absolute value. I'm going to ask my student to pause the video, try this one on his own. Let's see how it goes. Go ahead. All right, so hopefully he turned that immediately into a 42 plus f equals negative 8. And then we have this 42, so obviously we got to get rid of it, so it's going to be minus 42, minus 42, and then we're going to cancel, and then we're going to have f, and then we're going to have, negative 8 minus 42. Once again, number line trick, negative 8 minus 42. That tells you where your man is standing, that tells you where your man is facing, that tells you how many steps he's walking, and then we end up with, that should be negative 50. I leave it to my student to check that on his own. All right, this one we have absolute value of negative 31. So that immediately is going to be rewritten as something else that's easier on the brain. I asked my student to pause this and try it on his own. Good luck. All right, so the way that one works is t plus 31 equals negative 6. Because the absolute value just turns that into a positive. In order to get t by itself, we got to subtract that 31 from both sides. And what happens as a result of that? Well, when we subtract 31 from both sides, it's amazing. It becomes t equals, okay, what do we have over here? We have that annoying, we have a lot of negative numbers, which are annoying. So this tells you where the man is standing. This tells you where the man is facing. This tells you how many steps he's walking. It turns out that it's going to be negative 37. Moving on. 1 is 6. Okay, we got 3 more here. Let's take a look. We'll do a little divider. I can already foresee that's probably going to be smart. So looking at this first one, apply the exponent. What is negative 3 squared? Negative 3 squared is really negative 3 times negative 3. Well, first of all, it's a negative times a negative, so the answer is going to be positive. Second of all, it's 3 times 3, so it's going to be a positive 9. So really, what we're dealing with here is 2, negative 2 equals positive 9 plus m. All right, I leave it to my student to do the rest of this. Please pause the video and try unpause when you're ready for the answer. Okay, so hopefully he tried that, and anyone at home watching tried that. So we have minus 9, and then you end up with cancel, and you end up with m. Okay, what's negative 2 minus 9? Well, once again, unfortunately, or fortunately, if you're getting the hang of it, this is, negative 2 minus 9. First number tells you where your man is standing. Second symbol tells you which way he's facing. Next number tells you how many steps he's walking, and that's going to turn out to be negative 11. Boom. All right, negative 3 squared. Notice how this exponent is not being applied to the entire negative 3. Okay, we're going to look at this with a microscope, okay, because this is really, really important. This part's really important. If you notice here, there was negative 3 inside parentheses, and that was raised to the second power. This is not in parentheses, and what that means is this 2 is only getting applied to this 3 right here. There's this negative symbol that's unaffected by that exponent of 2. That's hugely important. So the teacher is literally trying to trick you right now, where your teacher is trying to test your ability to know that this 2 is only getting applied to just this 3 right here. I'm going to wrap the 3 in parentheses. Notice how this negative is not involved in that 2. Okay? So whenever you see a negative 3 raised to whatever, but the negative is not in parentheses like this was, just know that the 2 only gets applied to that. Now the bottom line is 3 squared, just 3 squared is 9, but the negative stays there. The negative remains unaffected by that exponent. So we're going to rewrite this as negative 1 equals negative, because the negative's unaffected, 9 plus n. Okay? Now I leave it to my student to do the rest from there. Okay, hopefully we added 9 to both sides. We're going to take this whole situation over here. And then as a result of adding 9 to both sides, cancel. So we end up with n equals, what's negative 1 plus 9? Well, hopefully you would realize negative 1 plus 9 could be rewritten as 9 minus 1. So that ends up becoming 8. I'll leave it to my student to check, plug 8 back in, and see if it works. All right. Okay, negative 2 to the third in this. Okay, so already this is all a bunch of gobbledygook nonsense. So we're going to have j plus, what is negative 2 to the third? We're going to go off to the side and do that right now. So negative 2 to the third is really negative 2 times itself, 3 times. So let's focus here and here. Negative 2 times negative 2 is positive 4. So we got to carry this one down though. So that's still a negative 2. Okay, so positive 4 times negative 2, what the heck's that? Well, that's going to be negative 8. So really, this is negative 8. So I'm going to rewrite that as negative 8. Now we already know that absolute value turns everything positive, so that's going to become 7. Also, my student at home definitely knows that when you add a negative, that could be rewritten as j minus 8. So you have j minus 8 equals 7. And then we're going to add 8 to both sides, obviously. I'm kind of just doing this one. So we're going to add 8 to both sides. And as a result of that, we end up with j equals 7 plus 8 is 15. That is a flashcard memorization type situation. All right, so before I sign off here, I want to give my student an opportunity to do something like that. Something like that. So we're going to say x plus negative 4. Well, you know what? I'm going to say negative 1 to the third equals absolute value of negative 5. So I leave it to my student to pause the video and try that on his own. I'm going to give my student an opportunity to do a problem that's very similar to that. So go ahead, pause the video, give it a shot. Okay, well, hopefully my student realized that that's, negative 1 to the third power. Well, what the heck's going on over there? Well, that's really negative 1 times itself 3 times, right? Negative 1 times negative 1 times negative 1. So these become positive 1. Negative 1 times negative 1 is positive 1. Carry that negative 1 down. These become negative 1. So ultimately it just becomes negative 1. So we have x plus negative 1 equals, and then hopefully my student realized that that negative becomes a positive, so that's going to become a 5. And this could be rewritten as x minus 1 equals 5. And then adding 1 to both sides is 6. Okay, so I didn't actually write plus 1 plus 1. I'm saving room right here. So just know that I added 1 to both sides. That canceled out that negative 1, and 5 plus. And therefore, that's the answer. Okay, so hopefully that makes sense. I'm going to wrap that up in a yellow box. Okay, so I had limited time to do this, but hopefully that's helpful. Obviously, the front end of this video is a little bit more heavy with the explanations. The back end of this video, the last half of this video, had more to do with just running through the problems, assuming that we sort of understand the steps involved. You know, some of the fundamentals regarding the steps involved. So hopefully my student at home, hopefully that's helpful. Good luck. My student at home has a test tomorrow. And as long as you actually did this, as long as you actually tried it and learned from your mistakes and all that good stuff, you should do well. You should do well. As long as you tried it and learned from your mistakes, it should work out. Okay, so for the rest of you watching this, hopefully it was helpful. And I will talk to you later. Bye.